Rates and initial values. If we take any function, the average rate of change between x1 and x2 is, by definition, the difference between the y values for these 2 points and the difference between the x values. So this is assuming this point is x1, y1, and this one's x2, y2. Now, this equation might look very familiar to you guys, and if it does, it is precisely because for a line, we always get the same exact number here when you take 2 different points on the line. You always get a consistent number called the slope. Now, when we do word problems, we're going to call this rate of change, or slope, a rate. So you're going to be asked to find a rate when actually for linear equations, it just means slope. So this m is just a rate. Okay, so let's look at an example. The average weight of a male child's brain is 970 grams at age 1 and 1,270 grams at age 3. Assuming that the relationship between weight and age is linear, what is the rate of change of a male child's brain? So let's actually draw a little picture or a graph to help us better understand the situation here. We're essentially told that the weight of the brain of a kid is dependent on the age of the kid. So if we know the age of the kid, for example, maybe the kid is 1, we know that the weight of that kid's brain is about 970 grams. So the kid's brain is about 970 grams when they're age 1. We're also told that at age 3, the average weight of the child's brain is 1,270 grams. So we're basically told that there's this relationship between weight of a kid's brain and their age, and it looks like, as the kid gets bigger, their brain weight goes up. Now, we're told that we're going to assume this assume that the relationship is linear. That means that we can assume that there's this pattern for all ages in between 1 and 3 and, a little bit younger and a little bit older than 3, where we can assume that at age 2, the weight of a child's brain is somewhere in between 970 and 1270, and it falls exactly on this straight line here. Okay, what question are they asking us? They want to know, what is the rate of change of a male child's brain weight? So essentially we're being asked to find the rate of change of this line. In other words, the slope of the line. So we're going to figure out, what is the slope of this line? Now we know how to find slopes of lines. How do we do that? If we have 2 points on the line, which we do, one at 3, 1270, and one at 1, 970, we can actually find the slope by using our slope formula. So we know slope is equal to y2 minus y1 over x2 minus x1. So if we just plug these numbers in, I'll assume that this is our second point. So we'll assume that this is x2, y2, and that this one is x1, y1. And if we plug these numbers in, we get 1270 minus 970 divided by 3 minus 1. In other words, we are going to get 300 over 2, or 150. So what is this number 150? It is the average rate of change of a male child's brain weight over time. Okay, so the rate of change of a male child's brain weight is 150. Now we need some units here because this is a word problem. So what are our units? Well, we can find our units by just taking a look at what these y values are and what these x values are. So the y values are weight. That's what our y-axis is. So y values are weight. Let's write that down. And then the x values, they're age. So this is age. Now our weight, we're told, is in grams. So we come up here, we know that our weight was in grams. And our age is measured in years. We'll assume it's years. It says age 1, so we assume that's years. So our units are going to be grams and years. So we're going to divide grams by years and say that the rate of change of the male child's brain weight is 150 grams per year. And so the units are going to just exactly correspond with what the units for the y values are, divided by the units for the x values. Okay, let's look at a second example. A kitchen appliance manufacturing company determines the total cost, C, in dollars of producing X units of a blender is given by the equation right here. So it's given by this equation. We want to answer these two questions. We want to find the rate of change in this equation, and we also want to know what the initial value of this equation is. So we still need to define initial value. So let's do part A first. Now, we are given this equation, C equals 25x plus 3,500. Okay, and so let's think about what this means first. So we have a function. It's a linear function where the y-axis is c and the x-axis is just x. Now remember, this 25 here is the slope, and then 3,500 is our b value or y-intercept. So if we were to kind of get a quick sketch of what this line looks like, it would have y-intercept at about 3,000, well, exactly 3,500, and then it has slope 25, which means every time you go over by 1, you go up 25. So it's like a pretty steep line. If we go over 1, we have to go up 25. Okay, so we don't need like a really precise graph, but it helps us, start thinking about what's going on here. So what is the equation saying? It is saying that the cost of producing X units of a blender is given by this equation. So if you want to produce more units of a blender, in other words, if X gets bigger, you want more units of a blender, then the cost is going to go up. And it's going to go up by 25x for every X you increase by. Now, we have seen that rate of change is the same as slope. So remember, rate of change of a line equals slope of the line. So our rate of change here is just going to be equal to what the slope is, or 25. You can read it off from this equation. So m is 25. We can read it off from the equation. Now, what are our units? So the units are going to be the ratio of the y units divided by the x units. So it's going to be y units divided by x units. Now, the y units is cost in dollars. Now, x, we're told that that is just x units of a blender, so it's kind of vague. We'll just say it's like units of blender. Okay, so our rate is just going to be $25, the y units, divided by units of blender. Okay, so that's part A. So rate, if you have a line, is just the slope. And then the units are the y-axis units divided by the x-axis units. Okay, now what about initial value? So what's an initial value? Let's take a look at that. Initial value is the output you get when your x-axis variable is 0. So this is like output you get in the function when input is 0. So if we take our equation, which is c equals 25x plus 3,500, we can find the initial value by plugging in x equals 0. In other words, c is equal to 25 times 0 plus 3,500, or 3,500. And then we just need to use units. So, we need to figure out what the units are. So let's think about this. If you plug an x value in for this thing here, for x, you put a number in here like 0, the output is a c value. In other words, the output is some value on the y-axis, c, which is in dollars. So for any input we plug in, our output is going to be in dollars. So our initial value is $3,500. That's like sort of like our getting started cost. It's like the money we have to spend before we even start producing anything. Okay, so just to summarize, if you're ever given an equation in the form y equals mx plus b, the m value, that's your rate, and the b value, that's your initial value. And so the initial value comes from when x is 0, and so this part goes away, and this gives you the initial value. And then you just have to figure out what the units are.